Welcome to EDU World Space.
So here's the problem 23.8. In this question, we're going to find which of this crystal field splitting diagram will represent the following conditions. Part A, we have a weak field complex of iron 3+. So for this one, the electron configuration of iron in neutral state will look like this. Ar4s2 3d6. So for iron 3+, it will lose 3 electrons. So from the most outer to inner, so it will lose all the electrons from 4s. So it will remain as 3d5. Alright, so there are 5 electrons in the 3d orbitals for Fe3+. And in octahedral ligand field, the T2G orbitals gets lower energy and EG orbitals get higher energy. And as it's a weak field of complex, pairing of electrons will take place only after all the 5 d orbitals are half-filled. So pairing goes after half-filled. So the crystal field splitting diagram that represents the weak field octahedral complex of iron 3+ will look like this. The higher energy is the EG orbital. The lower one is the T2G. And we have the 5 electron half-filled in each of the orbitals. Alright, so compared to the 1, 2, 3, and 4, we see that this is the same as the diagram 4. So part A has the diagram 4. Part B says a strong field complex of iron 3+. So similar to the first one, iron 3+ also has the electron configuration as Ar3d5. So there are also 5 electrons in 3d orbitals of iron 3+. In octahedral ligand fields, we said that T2G orbitals gets lower energy than EG orbitals. And because it's a strong field complex, all the electrons will take place in lower energy level. So they will be preferably in the T2G orbitals and then goes to EG. So the crystal field splitting diagram in this case EG T2Gs. So we have the 5 electrons, 1, 2, 3, 4, 5. So compared to the choices 1, 2, 3, 4, we can see that this is the same as the option 1. So the correct option for part B is number 1. Now part C. Part C, the question says a tetrahedral complex of iron 3+. Alright, so consider a tetrahedral complex of iron 3+. The electron configuration of Fe3+ is still the same as Ar3d5. So there are 5 electrons in 3d orbitals. And in tetrahedral ligand field, the E orbitals gets lower energy than T2 orbitals. So all tetrahedral complexes are weak field complexes. So because of weak field complex, electrons will preferably goes half filled and then to pairs. So the crystal field splitting diagram will look like this. This is the T2, and the lower one is the E orbital. And the electrons will be half filled in all of these places. So compared to the choices 1, 2, 3, and 4, we see that this is the same as number 3, tetrahedral complex of iron 3+. Now part D, consider tetrahedral complex of nickel 2+ iron. So the electron configuration for nickel in neutral atom will be Ar4s2 3d8. So nickel 2+ will lose 2 electrons. So the 2 electrons from 4s orbitals are gone. We have 3d8. So there are 8 electrons in the 3d orbitals for nickel 2+. And in tetrahedral ligand field, the E orbitals get lower energy than T2 orbitals. And all tetrahedral complex are weak field complex. So for weak field complex, pairing electrons will take place only after all the 5d orbitals are half filled. So in this case, we'll draw the crystal field splitting diagram like this. The lower one is the E, so T2. So we have 8 electrons, 1, 2, 3, 4, 5. So after it's half filled, it's starting to get paired. 6, 7, 8. Alright, so this is the crystal field splitting diagram for part D. And compared to options we had, this is the same as number 2.